Ever stop and think about how our incredibly complex digital world actually gets built? Every app, every website, it all has to start with some kind of plan. Well, today we're going to look at the OG blueprint, the very first model that tried to bring order to the chaos of creating software, the waterfall model.
Okay, so let's get right into it. The name waterfall is actually perfect. I want you to picture water flowing down a cliff. It only goes one way, right? Down. That is the absolute core idea here. It's the super strict, step-by-step process where you have to completely finish one phase before you're even allowed to start the next. There's no swimming back upstream.
Now, this whole idea isn't new at all. Its roots go way back to the 50s. But it really blew up after a 1970 paper by a guy named Winston W. Royce, who introduced the diagram we all know today. It quickly became the first real, formal, common-sense way to manage these huge, messy software projects. In fact, it was so influential that by 1985, the U.S. Department of Defense made it their official standard.
So, how does this one-way street of software development actually work? Let's break down its anatomy, and you'll see just how sequential this whole thing is.
It all kicks off with requirements. This is where you try to get every single need from the customer down on paper. And once that's done, it's locked in. Then you move to design, where you draw up the blueprints. After that, it's development, the actual coding. Then you test the whole thing for bugs. Then you deploy it, you give it to the customer, and finally, maintenance, for fixing things that break later on. Now, the absolute golden rule here is that each phase is like a locked room. You have to finish everything inside before you're given the key to the next one.
To really get this, imagine you're building your dream house. You give the architect the plans, they hand them to the builder, and then for a whole year, you're not allowed to even look at the construction site. The day you finally move in, you walk through the door and realize the kitchen is tiny, not what you wanted at all. Well, that's the exact trap the waterfall model sets up.
So, this process sounds pretty logical, right? Step 1, then step 2. What could possibly go wrong? Well, it turns out this very logical flow has a massive, critical flaw baked right into its design. And the most fascinating part? People knew about it from the very beginning.
The biggest issue is that it's completely rigid. If a client changes their mind halfway through, sorry, too late. There is zero feedback loop, which means a small mistake in the design phase might not be caught until the very end, when fixing it costs a fortune. And teams can't even work at the same time. Coders are just sitting around waiting for designers who are waiting for analysts. It's just wildly inefficient, and it all adds up to a ton of risk.
And this brings us to the most ironic twist in this whole story. Remember Winston Royce, the guy who made the model famous? Well, he never, ever said it was a good idea. In his original paper, he called this strict one-way process risky and invites failure. His entire paper wasn't about promoting this model, it was about how you had to change it and add feedback loops to make it even remotely workable.
So what's the actual real-world cost of all this risk and inflexibility? Well, it all leads to this number. Yep, a pretty staggering 60%. That means 60% of the entire effort on a waterfall project can end up being spent on maintenance. And let's be clear, that's not adding cool new features. That's just fixing all the mistakes, all the misunderstandings, all the design flaws that were only discovered after the finished product was already in the customer's hands. Think about it. The majority of the work happens after the project is supposedly done.
Okay, so you're probably thinking, if this thing is so flawed and so risky, why are we still talking about it? Why is it one of the first things you learn in software engineering? Because its story isn't just about failure. It's about being the foundation that everything else was built on.
Let's be fair and look at the trade-offs here. Its biggest strength is its simplicity. The steps are super clear, the milestones are obvious, and it forces a design-before-you-code discipline, which isn't a bad habit to have. For the right kind of project, this rigid structure can actually be a good thing. And believe it or not, it does still have a place. The waterfall model can be a great choice for smaller projects where you know for a fact what the requirements are and they are not going to change. If you know exactly what to build and how to build it, this straight line can honestly be the simplest way to get from A to B.
But really, this is the waterfall model's true legacy. It was the essential, flawed first draft. Its failures were a masterclass that taught the entire industry about the critical need for flexibility, for customer feedback, for iteration. In fact, all the modern flexible methods we use today, like Agile, were created as a direct reaction to the problems that waterfall laid bare.
So, I'll leave you with this to chew on. The waterfall model showed us how important it is to have a plan, but all the methods that followed showed us it's just as important to be able to change that plan. So it really makes you wonder, How does the ghost of this first rigid blueprint still shape the way we work, even in the most flexible and modern software teams today?